All right, so here are the video solutions of the 6.1 to 6.3 quiz review. Number one is just a graph, and this is an exponential function. The base is 7, so that means exponential growth because the base is greater than 1. There's nothing multiplied by it, so it's just your normal exponential growth graph. It goes through 1 comma 0, or I'm sorry, 0 comma 1. The y-intercept is 0 comma 1. This part of it, there's an asymptote. It shouldn't look like it goes back up like mine does a little bit. It's going to just approach that x-axis and keep approaching it like so. But that's it. Number two is 0.3 to the x. So it's essentially the same type of function as this exponential function. But now the base is not greater than 1. It's less than 1. It's between 0 and 1, I should say. So this is exponential decay. And it's just your normal exponential function. There's nothing multiplied by it. There's like no number in front of it like this. So it does go through the normal point 0 comma 1, but it's decay. And now its horizontal asymptote is going to be on the right-hand side. That's it. That's the difference between this one and this one. Now the next two are the natural exponential functions. So these are a little bit different because e is the base. So think of them like this. So e to the negative 3x, for a base of e, if you have a negative exponent like that, it's decay. So it's your normal exponential function that comes down like so. The difference is this does not go through 1. It should go through 3.5 because you're multiplying 3.5 times this whole thing. So where it normally was at 1, it's now at 1 times 3.5. So the final answer graph would look like this. It goes through 3.5, which is right here. And then you do want to show that this graph does keep going down and has an asymptote as the x-axis. So that wasn't the best drawing. I'm going to redraw it. Like that. So this one is, and that was decay because of the negative exponent. I'll circle that. This one's exponential growth because the exponent is 5x, positive 5x. So it's going to grow, and the y-intercept would be 1/2. So it's going to go through the y-axis here, and I'm going to show it as a growth graph, which is going to look like this. So those are the graphs. So let's do the simplification. Now, rules of exponents. If you're multiplying exponents with the same base, you add. If you're dividing exponents with the same base, you subtract the exponents. And if you raise an exponent to a power, you need to multiply exponents. Now, all of these have the same base. They're all e. So for this one, since you're multiplying, you're going to add all the exponents. 2 plus a negative 10 plus 4 is 6 plus a negative 10. Now I'm going to take it one step further because when you have a negative exponent, you move it, in this case down, and make it positive. The next one, same thing. You can see up top you're multiplying exponents with the same base, so you just add the 2 and the 10. And then now we're dividing exponents with the same base, so you just subtract the 5 from the 12, and that's e to the 7th. For number 7, when you raise a product to a power, you have to raise each factor in there to the power. So this 4 would be applied to the -2. So it's -2 to the 4th. And also the e to the -10x to the 4th. So when you raise -2 to the 4th, you're multiplying -2 by itself 4 times. So -2 times a -2 is 4. Times a -2 is 8. Times the -2 is a -8, and then -8 times a -2 is +16. And then now we have an exponent to a power. So all you do here is you multiply the exponents. That's a property of exponents. So you just do -10x times 4 is -40x. You can leave it like that, but you could also move that e to the -40x down and make it e to the +40x. If you do, make sure you don't take the 16 with it, because the 16 is not raised to that exponent. Either answer here is okay. So I'm going to flip the page. I'm going to do the next 6 because those are very simple. And then the next video will cover the logs. So you're writing an exponential form, so you use that triangle method. So the base is 3 of this exponent. So I'm just going to go 3 to the 5th equals 243. I wrote 3, I meant 2. So and then that's the same for all of them. But for number 9, you have to remember that the natural log has a base of e. It's just not written. So you can write it in and just go e to the -23 equals 5x. Done. We're not supposed to do anything further. We're just writing an exponential form. Now, see this log here? You don't see a base like you saw over here. So if you don't see a base on a log, it's base 10. So you can write that 10 in and just do the same thing. 10 to the -3 equals this, which is 1 over 1,000. So those are all in exponential form. The next 3 are logarithmic form. So the first one is a log base 10, and then just do that triangle again. Log base 10 of 10 equals 1. Now log base 10, log base 10, that's understood. You don't need the 10. So you will see this written. I'm just going to erase that little 10 like this. If you keep the 10 as the base in there, that's okay. So now this next one, log base e. Now I'm going to change that because you don't see log base e. That's going to become a natural log, but I'm just going to follow the rules here. Log base e of 4x equals -4 equals -40. Now log base e is the natural log, so you write it as ln instead of log base e. That's it. And finally, the last one is pretty simple. Log base 3 of 13 equals 12x. And now it's in logarithmic form, and we are done with that set of problems. So I'm going to stop that video here. We're going to go to the next ones, the evaluate the logs. We're going to make a whole separate video on that. They're a little bit more involved. So if you'd like to watch that one, that's next.